Good afternoon. I want to start off by saying that one of the things I really love about Angular is how easy it is to build reactive applications with it. But over my past few years building reactive Angular apps, I've come across a few pitfalls that I've sort of stumbled into. So let's start by taking a look at some examples. Let's say I've got an Angular component, and its template looks like this, where I've got some observable, and I'm trying to read its value out, and I get it with the async pipe. Everything looks fine, but then I go to the component's implementation, and I notice that the observable is actually being defined with the HTTP client. So what's the problem here? Let's go look at that template, and you'll notice that I'm using the same observable twice. I'm passing it into the async pipe 2 times. And this is going to cause me to subscribe to that observable 2 times. And that's going to cause me to make that same HTTP request 2 times. So this isn't quite a good solution. I need to find some way to refactor this. So I choose to refactor it to use the ngIf as syntax. So now I'm passing in the same observable using the async pipe, but I'm just doing it once. And I'm exporting that value to my template using the as syntax to assign that value to a movie's property. Then I can use that variable in my template multiple times without causing multiple subscriptions. So this looks pretty good. I've fixed that first problem. But what happens if I want to use multiple observables in this template? Well, it starts to get particularly messy. So this solution won't scale up for components that have lots of different observables they need to consume. Another refactoring technique that I could go about with is I could go back to my component's implementation, and instead of exposing the observable directly to the template, I could choose to instead subscribe to the observable and assign the value to a property on the component instance. So here I'm subscribing to the observable, and I'm assigning its value to a property on the class. So this works pretty OK, except there's one problem. If this was not an HTTP request, we might be potentially leaking memory by not actually having the subscription cleaned up when the component is destroyed. So I go back through, and I make one more refactor, and I change it to have a subscription property on the class. Now I'm subscribing to the value, and I'm assigning the subscription to a subscription property on the component. And then in ng-on-destroy, I unsubscribed to clean up that request. Things are looking pretty great. I've fixed a number of problems, and I've got a code sample that's working well. But then I encounter some kind of error with this observable, and the stack trace that's produced is really difficult to parse. There's lots of things to do with Zone.js that isn't really meant to interact with my code, but it's making it difficult to track down what the problem is. So each of these pitfalls have me thinking, can we provide a better experience for building reactive Angular applications? And I think the answer is yes, but I want you to help me build this. So first, let me introduce myself. My name is Mike Ryan. I'm a software architect at an IoT company based out of the States called Synapse. I'm also a Google developer expert in Angular web technologies, and I'm one of the co-creators of NgRx, a project trying to bring reactivity to the Angular framework. So what are my goals for improving reactivity? Well, first, I want to make it easier for developers to use values directly in the template without having to use the async pipe. But the async pipe has that really great benefit of cleaning up our subscriptions for us. So I also want to make sure that if we're not using the async pipe, it's easy for developers to not accidentally link memory. I also want to make it possible for developers to build these Angular applications without Zone.js to improve debugging experiences and to maybe make the apps a little bit more performant. So how do we go about this? Where do you start if you want to try and create an open source library? Well, for me, my favorite place to start is from a top-down perspective. I like to think about the API of my library. What's the experience going to be like when developers try to consume my project and their code? So I have an idea for the API in mind, but before I show you the design, I kind of need to explain how change detection in an Angular app works. So you can sort of step back and think of an Angular app as a tree of components. At the very top is your root component, the app component, and then beneath it, in different nodes in the tree, represent other components in your application. When a user interacts with one of these components, that component gets called or marked as dirty. And all this really means is that that component's template needs to be re-rendered. Something about its internal state has changed, causing the view to need to be adjusted. Then Angular runs change detection. And it does this by walking down the tree, checking all the components that are dirty, and re-rendering them if need be. So what do zones have to do with change detection? It's kind of a misconception, but zones aren't actually a part of the change detection mechanism. Instead, they instruct Angular when to run change detection. And they do this by patching all the asynchronous APIs in the browser. And when your code interacts with those APIs, zones tell Angular, hey, it's time to walk that tree and perform change detection. But there's two downsides to this approach. The first is they can potentially run change detection too often. So if you've ever built a reactive Angular app where maybe you're connecting to a really noisy WebSocket connection, you may have experienced performance problems from zones instructing Angular to run change detection too often. On the other side, you may cause your application to not be rendered if you're using a particularly, let's say, new or unusual browser API that zones hasn't been updated to patch yet. So you interact with the API, and then you expect your app to update, and it just doesn't. And it can be really hard to debug. So if we're going to try and replace zones, we need to come up with an alternative method to trigger change detection. And this is where I want to give you a big piece of advice if you want to try and create open source libraries. And that's to look around and learn from others around you. It's totally acceptable to look at how other frameworks and technologies and languages are solving these same problems. By learning from them, you can bring those same great ideas into your own communities, and we can all benefit from it. So I'm going to do something a little taboo here. I'm going to show a bit of React code in my code. Because React kind of handles this in a pretty interesting way. React has this idea of component state. And state is just a term for the values that change over time as the user interacts with this component. You then bind that state directly into your React components template. When that state needs to change, you call the state's setter function. That updates the state, but it also tells React, hey, the underlying data that this component depends on has been updated. It's probably time for you to run change detection. So there's some pretty cool benefits to this. The first is that it's changes to state that cause change detection to run in a React application, not interacting with asynchronous APIs like Zone.js. This means the developer has more control over change detection. When you call a state setter function, you are triggering change detection in a React application. And I have found that by using this approach, my UIs built in React tend to be a little bit more consistent. I can control the performance characteristics of it, and that state is what's directly bound to my template. So there's some pretty unique ideas here. And if we want to try and bring these ideas to Angular, we're going to have to overcome a pretty big problem. And that problem is that Angular doesn't have a notion of component state like React does. But maybe it does. Because if you're using something simple, like a behavior subject with a service, or something more complex, like NgRx store, then you are using a state mechanism to track changes. It's just that state mechanism happens to be observables. As Angular developers, we tend to reach for observables as the main mechanism for tracking state changes in our Angular applications. So what does my proposed API look like? Well, I think it looks a little bit something like this. In our Angular components, we'll define what kind of state our Angular components need, and then we can use some kind of maybe connect hook in the constructor of our components to tell Angular how to get that state and where those sources are from. And we'll do that by passing in a dictionary of observables for each piece of state we want to track. Then, once you have your state connected, you can use it directly in the template. You can now just use the state object directly without having to rely on an async pipe. So now I've got my API design in mind. What's step 2 for creating an open source library? Well, step 2 is to start tinkering around with the idea. And for that, we're going to need to build a demo application. Just a small Angular app that we can start to toy around with these ideas in to get a feel if this is going to work or not. And I think we probably want to use Ivy here for a few reasons. The first is that Ivy is going to enable us to build something called a higher order component. Now, I'll touch on this in a bit, but the idea is that we want to inject some custom behavior into our Angular components. The second benefit is that there's some new change detection APIs in Ivy that are going to enable us to work around Zone.js a little bit easier. So here's the demo app I've built. I've built this app like 30 times in my life. It's just a simple counter application. So as the user interacts with the application, state changes, the counter increases, and everything kind of works as you'd expect. So here you can see I'm pressing the plus and minus button. The number is changing. This represents state changes and interactivity. I also like this app because I can fit the entire code for it on one slide. So this is the entire application. It's just one Angular component. And the way it works is I've got a stream of values, and when you press the plus or minus button, I either push a -1 or a +1 into that stream. From there, I'm going to use the scan operator to add those values up to a count. So when I add a +1, the value will go up by 1. When I add a -1, the count will decrement by 1. So now that I've got my demo application, I need to do two things. First, I need to enable Ivy, and second is I need to remove Zone.js. Thankfully, today, it's easier than ever to get started building Ivy applications. All you have to do in your app right now to start using Ivy is run ngupdate command and update Angular core and Angular CLI to the next tag. This will run schematics that will automatically upgrade your code to use Ivy by default by getting you on early releases of Angular 9. From there, I need to disable Zone.js. So I'm going to go into my polyfills.ts file. I'm going to go look for the line where I'm importing Zone.js, and I'm just going to comment it out. I need to let Angular know that I've done this. So I'm going to go into the main.ts file where I'm actually bootstrapping my application, and I'm going to tell Angular, hey, there's no zone running in this app. Now if I run it, it renders, Ivy's working, but interacting with it doesn't cause the value to change. And this makes sense. Zones was the mechanism that told Angular when to run change detection. By removing zones, no one is telling Angular, hey, it's time to check if the view needs to be re-rendered. So let's start by trying to fix the change detection problem. And for that, we're going to need to explore some new Ivy APIs. So in our applications today, if we want to trigger change detection manually, we inject something called the change detector ref. Using that change detector ref, we can then call detect changes, which will immediately run change detection. There's two downsides to this approach, though. The first is that I have to actually inject something into the component. This is going to make it difficult to refactor this code out into a reusable module of code. The second downside is that when you call detect changes, change detection runs immediately. So you can't call detect changes multiple times in the same frame without incurring a performance penalty. In Ivy, this gets so much simpler. There's a new function called markDirty, and all you have to pass to markDirty is an instance of a component. You don't have to inject anything. It just works directly. And we can actually play with it in the browser's console. So here I've got the app. I'm going to use the new ngProbe API to get the component instance. I'm going to push a value into my subject. And then I'm going to use the probe to mark that component instance as dirty, which will run change detection for us. But if we're going to build our entire open source library on top of markDirty, it's important to understand what it's doing underneath the hood. So markDirty does 4 things. I've kind of dug into the source code to suss this out. The first is that it gets the view data for the component instance that we provide it. So underneath the hood, Angular has a bunch of data about the view for our components. And it just sort of maintains this binding between the two of them. So first thing it does is it looks up that binding, gets the view data. From there, it marks the view as dirty. This seems familiar to us. This is how Angular works today. This means that the next time change detection runs, that view will get recreated. Then it does something pretty interesting. Unlike in an Angular application today, markDirty in an Ivy app then walks up the component tree to find the root of that component tree, our root application component. And it uses that component to actually schedule change detection. So before markDirty wouldn't have run change detection, now it does. And it's not doing it synchronously like the change detector ref. Instead, it's using a scheduler underneath the hood. It happens to be a request animation frame, which means we can call markDirty multiple times in the same frame without incurring a performance penalty. So how do we use this in our Angular components, right? We saw how to use it within the console, but now we want to build applications with it. Well, if we go back to our app component, the first thing we need to do is we need to actually import the function. you'll notice that there's a theta in front of the function right now, because this is not a stable API. So don't go running out and putting this in your production code, because the ergonomics of this API may change over time. But for now, I'm going to use import as syntax to get rid of that theta, and then I can use the tap operator at the end of my count observable to call mark dirty on my component instance. If I run the application now, you'll see that the application is working again. The user interacts with it, the value goes up and down, it's all working with Ivy without Zone.js. It's pretty cool. But if I'm going to be building applications like this, I don't want to be the one to call mark dirty. I know that I'm going to forget to call it so regularly if I have to call it manually every time. So how can we move that responsibility of calling mark dirty to a different module of code? And that's where higher order components is going to come into play. So a higher order component is another one of those ideas that we're borrowing from other ecosystems. And the idea is that we can modify the behavior of a target component. We can change something about the way that component runs. Here's something kind of interesting about them. I don't know how we as a community are going to author these yet. There's lots of different strategies. You could do it with decorators or functions or inheritance. But it'll be curious to see over the next coming years, as we start to build more things on top of Ivy, which path as a community we chose to follow. For this example, I'll use inheritance. And they can call these new Ivy APIs underneath the hood for us. So let's take a look. This is our API design. This is has the connect hook that I've talked about. And I think we can get pretty close to this target API design with a higher order component. So here I've created a higher order component. It's called reactive component. All you have to do to opt into the behavior of this higher order component is to extend it. From there, you can then use the connect method to connect observables up to this component. This will subscribe to those observables, write those values out to the state object, and call change detection for us. So this is now the final API, but okay, we've got the API and we've got the design, we sort of know how we're going to do it, but what is the real implementation going to be like? Now it's time to write that connect method. To do it, we're going to start by initializing what I'm going to call a sync. This is the object where we're going to write values to as our observables update. And we're going to return the sync to the consumer. That way they can use that state object directly in their template. Then I'm going to get an array of all of the keys in that dictionary of observables, and I'm going to turn it into an observable itself of every key. Using those individual keys, I'm going to merge map into the observable that that key points at. So if I passed in a dictionary and the key was books and it pointed to an observable of books, this will now get me to that observable. And what I'm going to do is I'm going to say every time this observable changes, I'm going to write the new value that I'm seeing to that state sync. At the end, I'm going to take that new observable that I've built up, I'm going to subscribe to it, and every time I see a new value come out, I'm going to call mark dirty. So I know this can be a kind of a complicated piece of code, but let me walk through it visually, what exactly it's going to be doing. So let's say I passed in a dictionary where I've got one observable, and it's an observable of vegetables. What's going to happen here is Connect's going to subscribe to it, and every time a value comes out, we're going to run change detection, and we're going to update that sync value. So now that we've got this implementation, we can go back to our app component, and we can refactor it to use our new higher order component. So we're going to get rid of that import. We no longer need mark dirty. Instead, we're just going to extend reactive component directly. Then we're going to call connect, and we're going to pass in our original count observable to the connect method. This gives us back a state object that we can use directly in our template. So now I'm going to go into my template. I'm going to remove the async pipe, and I'm going to use that state object directly. Everything seems to be looking like it's right, but there's one gotcha. If I go to run this application now, it's not going to work. There's something we're missing. And if I open up the console at this point, there's going to be an error in it. And if the stack trace isn't particularly helpful, I don't really know what it means it can't read some property node index of undefined. But if I look at the second line, get component view by instance, this is kind of familiar to me. I think I remember where this is coming from. If we go back and look at what the 4 things mark dirty is doing, the very first thing is it's trying to get the view for the component instance. So what seems to be occurring here is when I'm calling mark dirty, it can't actually find the view yet. So I dig into Ivy's internals a little bit more, and this is what I found out. When Ivy creates a component, the first thing it does is it creates an instance of your component class. That's the first thing it's going to do. Then it's going to initialize the view data that your component is going to need to track that view over time. It's going to bind these two together, right? Remember I said that Angular underneath the hood sort of keeps this binding in place. Once that's done and that binding is initialized, it's then going to call the onInit lifecycle method. So what we probably need to do here is we need to make sure we're actually waiting for onInit. So if I go back to the implementation of Connect that we authored, this is the problematic line of code. We are calling mark dirty on our component instance before the view data is there. We need to wait for onInit lifecycle hook to be called before we actually start marking our component instance as dirty. So that means we're going to have to use lifecycle hooks in our higher order component. Thankfully, this isn't too painful. If we go to our reactive component class, all we have to do is implement the lifecycle hook. In Ivy, it'll look up our inheritance tree, and it'll actually call the method for us. But I don't want this as a callback function. I prefer to use onInit as an observable so I can mix it up in my observable recipe. To do that, I'm going to create a new property that the child component can use so it can access these lifecycle hooks as observables as well. And I'm going to call this property onInit. And I'm going to assign it to a new replay subject with a buffer size of 1. When NgOnInit is called, I'm going to push a value into that subject. It doesn't matter which value. I'm just going to use true for now. And then I'm going to mark that subject as complete to let the consumer know that there will be no more values emitted from it. I'm going to do the same thing for onDestroy so that child components can use both onInit and onDestroy as observables. And now that I've done this, I can go back to this one line of code and I can make a change. I'm going to refactor it to use these new lifecycle hooks. So first, I'm going to use the concat observable factory to make sure that I subscribe first to onInit, and when that's completed, then I'll start subscribing to that update sync observable. So this guarantees that I'm not going to start writing changes out to that sync and calling mark dirty until onInit has completed. Then I'm going to use the take until operator, and I'm going to pass in the onDestroy lifecycle hook observable. This will ensure that all these subscriptions that I've created are cleaned up when the component is destroyed, so that the consumers of this library don't have to think about managing observable subscriptions. With this in place, now I can go and I can run the application again, and everything is working. The user can interact with it. They're writing less code to manage those subscriptions. There's no Zone.js at play, and the developer controls how state changes. And what's great about this approach is it works for all sorts of different kinds of state management approaches. So if you're using subjects with a service, you can just pass those in to Connect. That just works. Or if you're using something more complex like NgRx, you can pass the observables you're getting back from the NgRx store directly to Connect, and that works too. And what's really interesting is that libraries like NgRx and NGXS and Akita, they can take this one step further, and they can provide their own higher order components that remove even more of the boilerplate of connecting those observables to their component instances. So what have we achieved with reactive component? Well, we've made it possible for developers to use values directly in the template without having to rely on the async pipe. We've also made sure that developers aren't accidentally leaking memory. Reactive component manages subscriptions for you and automatically tears them down when your component gets destroyed. And we've made it possible to build entire Angular applications without Zone.js by relying on the fact that we use observables to track state changes in our Angular applications. So what do you think? Maybe you want to use reactive component. Maybe you're itching to start playing with it in your Ivy apps. Well, this is where the call to action comes in, because this doesn't really exist yet. I want your help building this kind of open source library. I'm really excited to announce a new initiative for the NgRx team called NgRx Component. NgRx Component is a brand new library in the NgRx family. And the goal of this library is to make it possible to build reactive Angular components. It doesn't exist. You can't npm install it. We're in the design phase right now. So if you hop onto our mono repo, github.com/ngrx/platform, you can get involved and help us design this library and help us build it. And I'm going to give you a head start. Here's the URL to all the code that I've just showed. It all works today. You can actually run it and start playing with these ideas. The slides are also attached if you want to see a reference for how these things were built. Thank you.